start with the new chapter, that is number system. That is the first chapter, and the introduction of that is that there are many types of numbers already which we have learned. The first one is natural numbers, which include the numbers 1, 2, 3 to infinity. That is all the positive numbers. Then the second pattern of number is whole numbers, which are 0 and all the natural numbers. So I can say all the numbers which start from 0 are coming in the whole number. Now the third pattern which we have already studied is integers, which include all the positive and all the negative integers including 0. That is, I can say -3, -2, -1, 0, 1, 2, 3 till infinity. So I can say all the negatives and all the positive numbers including 0 comes in integers. Now here we will start the new pattern, that is rational number. Now if I want to give the definition of rational numbers, it is said like rational numbers are the numbers which can be written in the form of P by Q. Now here P and Q both belongs to Z, that is integers, and Q can't be equal to 0. So taking the example of rational numbers, I can say 1 upon 2, -1 upon 2, 3 by 5, all are rational numbers. Or even I can say 3 by -5 is an example of rational number. Now then they are asking us one topic very commonly, that prove that three is a rational number. So to prove this, it is very easy. So 3 I can write as 3 upon 1. So which is in P by Q form, where P is equal to 3 and Q equal to 1, which is not equal to 0. Therefore 3 upon 1 is a rational number. Then one another question which they ask always is insert 5 rational numbers between 3 and 4. So this how I can do. 3 I can write 3 upon 1. 4 I can show as 4 upon 1. Now I can multiply numerator and denominator with 3, because directly between 3 and 4 I don't have any number. So I am multiplying both with 10. I can multiply with a smaller number also, but here I am multiplying with 10 to make it easy. So now between 30 upon 10 and 40 upon 10, the rational numbers are 31 upon 10, 32 upon 10, 33 upon 10, so on till 39 upon 10, and then comes 40 upon 10. So I can say I can find 9 numbers between the given two numbers. Now, moving forward, the next topic we are having is irrational numbers. Now, to say about irrational numbers, I can say all numbers which cannot be written in P by Q form are irrational numbers, or the other definition says all the number which are non-terminating and non-repeating, like I can say 1 0 1 0 1 triple 0 1, so on. It is repeating continuously. Then constant numbers like pi, which have infinite value. Then I can say like this. Here the numbers are not ending and they are not repeating. And also all the root numbers, that is root 2, root 3, root 5, root 7, root 11, root 13, root 15, or I can say all the prime numbers in root are also irrational number. But here in roots we can say that they can't be complete roots. That is, their root should not be possible, like root 4 equal to 2, root 9 equal to 3, root 16 equal to 4, so on. So such numbers are not possible, or they don't come in irrational numbers. Now, here one common question they ask: locate root 2, root 3, root 5, root 7 on the number line. And in the later part, we will be studying root 10.3, root 9.3, numbers which are coming in point also. So, here let us start with root 2. Locate root 2 on number line. So, to do it, it is very easy. First, I will make a number line. And you know that number lines are having numbers -1, 0, 1, 1, 2, 3, 4, 5. So that way I will be having the numbers on the root. And now one common question they ask every time, that is locate root 2 on number line. And even they can ask you locate root 3, root 4, root 5, root 7, root 9, root 11, any number they can ask you. And even they ask root 10.3. So that we will be doing in the later phase. First let us do for root 2. Now to do root 2, first I will need a number line. So I am drawing a number line. Now, you know very well that number lines are having negative numbers also, positive numbers also. So, I am locating some numbers, and this should be at an equal interval. Then only you will get the perfect diagram. Now, what we are going to do, we will be using Pythagoras theorem here. See, Pythagoras theorem. What was that? In a right triangle with hypotenuse, base and height. If I am given a right triangle, so hypotenuse square equal to h square plus b square. So suppose here hypotenuse I want root 2. So how I can get that? For that root 2 how I can get? If I get root 1 square plus 1 square. So 1 square is 1 and 1 square is 1. So I will get root 2. So to get that I have to draw or I have to take from the 0 1 unit, and that unit can be centimeter, can be inch, can be meter, as much big line I want. Now at 1 unit I have to make another 1 unit line which is perpendicular to this because it is a right triangle. So here I am drawing a perpendicular line of 1 unit. Now I have to join and I am giving that name A. Now I am joining OA, and with rounder the tip of the rounder should be at 0, and I will measure OA and I will put an arc like this on the number line. So this value will be my root 2. I hope you all have understood this. Now the next topic which we have to learn is decimal expansion. This is nothing but already we have learned, that is dividing a number by another number. For example, if I am given 7 upon 8 and I am asked to divide 7 by 8, so how I will divide? First I will write 7 and I am dividing it with 8. So in 8 table 7 doesn't come. So I will write 0 point and here I will write 1 0. Now I will go for 8 8s are 64. So now if I subtract 70 minus 64 I get 6. Again I will put 1 0 here and 8 7s are 56. So subtracting I will get 4, again 0 and I am getting 5. So 8 5s are 40. So I got remainder 0. If I am getting the remainder 0, this type of numbers are called terminating numbers. And there is no digit repeated. So they are only terminating numbers, but here it can be possible that some of the digits may repeat, so then it will be a repeating number. Now the second pattern of number is like, say if I am told to divide 1 by 3, so 1 by 3 if I divide, so 1 divide by 3, so it won't go, so 0 point, so here 0, so 3s are 9, 10 minus 9 will be 1, again 0, so 3s are 9, again 1 0, 3s are. So you can see the same digits are repeating continuously and I am not getting a terminating end. So this pattern of numbers which repeat, we write at 0.333 or even we write as 0.3 bar. That means bar means it only 3 digit is repeating, and this pattern of numbers are called non-terminating and repeating or recurring numbers. Non-terminating and repeating numbers it is called. Now let us take one more pattern in that, where I am taking a number 1 divided by 7. So again the same thing, 1 won't be divided by 7, so I am putting 0.0. 7 ones are 7, so remainder is 3 0, so 7 4s are 28. When I subtract I will get 2 0, so 7 2s are 14, 6 0, 7 8s are 56, 4 0, 7 5s are 35, 5 0, 7 7s are 49, 1. So now you can see the remainder has came 1. So again the whole series will start from here. So this type of number, if I divide 1 upon 7, I can say I will get 1, 4, 2, 8, 5, 7. Again 1, 4, 2, 8, 5, 7. So this will be continuing. Or I can say 0.142857 whole bar. This means K 1, 4, 2, 8, 5, 7 are continuously repeating, and this pattern of numbers are called non-terminating and repeating numbers.